All right. Hello, everyone. My name is Prashansa Agrawal, and I'm an Education, Society, and Human Development major with a double in psychology. My faculty mentors are Dr. Kinnari Atit and as well as Dr. Kathy Lussier. And today I will be presenting Does This Video MFit? Validating a measure of it for adaptive strategy inclusion. The MFit survey. The Mathematics Fidelity of Implementation tool, also known as MFIT, is a survey checklist designed to identify active and embedded learning strategies in supplemental instructional videos, or known as microtutorials, created by the mathematics department. With 31 questions, the survey consists of Likert design scale questions to assess the effectiveness of learning strategies. To view a full copy of the MFIT survey, please feel free to scan the QR code or request it at the very end. Moving on. What are active learning strategies and why are they so important? Active learning strategies are research-based cognitive strategies built into teaching and curriculum, which increase understanding and engagement for students. This can include methods such as building on prior knowledge, connecting to real-world problems, or offering pauses to allow students the time to process and ask questions. The MFIT survey utilizes 7 overarching active learning strategy themes, such as gestures, drawing diagrams, visually connecting parts of the problem to parts of the formula, referencing real-world examples, explaining mathematical language, vocabulary, and symbols, and the overall readability. These themes increase engagement and understanding, whether it be underlining keywords and then pointing them out continuously in the formula, or explaining key terms and their meaning in the context of a hypothetical math problem. This increases engagement, which is especially important when it comes to teaching that is not occurring in live time. Take, for example, themes 5 and 6, explaining mathematical language, vocabulary, and symbols. Oftentimes, those in a position of teaching know the material so well that they can feel like they are over-explaining. Similar to how I created this presentation, I became very accustomed to the information. However, for many of you listening, this may be the first time you're hearing about this information. Therefore, the MFIT survey serves as a tool to allow educators to identify successful learning strategies within materials that they create. With all this talk about successful strategies and improvement, I would like to clarify that A, math is wonderful, and B, that the mathematics department here is also incredible. Sure, math anxiety is a true cognitive issue that many face, and we often hear, especially from K through 12 students, things like, I hate math, or when will I ever actually need to use this? But math is so wonderful. It allows us to achieve so many things and accomplish many wonderful achievements. From NASA engineers like Tracy Dane and Swati Mohan that worked on launching giant pieces of technology into outer space and gather information about Jupiter and Mars, respectively, to the math required to create the 2024 total eclipse trajectory map. We can see that math shapes the future generation of STEM students and societal advancements. And this is just one field. Math is everywhere, from building bridges to accounting. So let's improve the potential of higher education gateway math courses. Calculus courses serve as an important foundation for many STEM fields. However, they can also become barriers for students, which deter them from continuing an education in STEM fields. Studies show that students who do not earn first-year calculus credit are more likely to drop their entire STEM field. Across numerous studies, regardless of what subject it's in, identifying evidence-based active learning strategies have found to increase student comprehension and engagement, which ultimately lead to motivation and persistence. The MFIT survey, to clarify, the MFIT survey is not designed to score the video, but rather highlight shortcomings or effectiveness of evidence-based strategies that are beneficial. In other words, it's not about saying that this video was good or that video was bad, but it's about identifying the efficacy of the video. The checklist serves as a guide for improving pre-existing resources while also creating new content that already has embedded strategies. Working to balance both parties, the MFIT checklist aims not only to support students and their learning, but as well as providing educators tools that help them develop stronger curriculum. Pilot testing. After finalizing questions for the MFIT survey, Professor Kathy Lussier conducted a pilot study in which 5 math experts and 5 novices from the education department viewed and evaluated 10 microtutorial videos selected by the mathematics department. This was primarily to calibrate the questions from the survey. Then, math and STEM experts ranked the microtutorial videos, the same 10, using the MFIT survey. After the videos were ranked in order of high efficacy to low efficacy, the 2 highest and 2 lowest efficacy videos were selected to be used in the first study conducted on participants. Overall, what the pilot study found was amongst the 10 math experts and novices, regardless of their expertise, they were in agreement when it came to identifying and ranking the videos based on the MFIT survey. In cases where there were discrepancies, it highlighted how and what novices, meaning non-math experts in this case, viewed differently from experts in calculus. For example, how mathematical vocabulary was based on prior knowledge. In one of the videos that covered pre-calculus concepts, math experts utilized the asterisk symbol to indicate multiplication. So on the survey, when it asked, quote, explaining vocabulary terms and relating them to common everyday casual wording, math experts marked this as varying levels of effective, while novices marked this as not present or non-effective. The MFIT Study 1. For Study 1, we posed 2 questions. A, to summarize, we asked, does the MFIT survey correctly identify active strategies and embedded learning tools to bolster students' STEM learning? And we also asked, is the MFIT a valid measure for differentiating between effective and ineffective instruction? For this study, I ran 30 undergraduate students that had taken Introduction to Calculus A or the equivalent. Participants were not restricted to STEM subjects, and each participant was scheduled for a 90-minute session in which they first completed a pre-knowledge screener, which consisted of 6 general calculus questions, again provided by the mathematics department. Then they watched the 4 microtutorial videos that were originally selected from the pilot study, and they watched those videos in the order that they were presented at their own pace. The order of the videos were presented in a counterbalanced way by creating 2 versions, which were switched every 5 participants. Additionally, the videos had 3 embedded questions, which served as the math achievement scores. The first question checked if the participant was paying attention, and the other 2 questions were similar to the content that was being covered in the actual video itself. After watching the 4 videos, participants were instructed to complete a math anxiety scale and a background demographics questionnaire. It is important to note that for the background and demographics question, they had 2 questions that asked participants to identify their preferred and applied learning strategies in math courses. Finally, the participants were also interviewed to 1, rank the 4 videos from most helpful to least helpful, and also explain their reasoning behind the way that they ranked the videos. All right, very briefly going over the descriptive statistics for the study, I wanted to highlight that the participants comprised of 3 ethnicity groups were a mix of STEM and non-STEM, which is different from their math status, and math status indicates whether or not they are math majors, particularly part of the CNAS group. And finally, according to the Underrepresented Minority Guide, 26.67% of our participants were considered in this category. Overall, the MFIT survey correctly identified effective calculus instruction from less effective instruction. Study 1 showed us that participants' average math achievement scores were higher on the videos with higher MFIT strategies as seen in blue. And this graph represents the t-test conducted after collapsing the 2 high efficacy and 2 low efficacy, high efficacy in blue and low efficacy in yellow, math achievement scores. Here we can see that the t-TEP indicated a statistically significant increase in math achievement scores for students when using the high strategy videos than the low strategy videos. This supports our question from earlier that the MFIT's tools bolster student STEM learning, as the survey is able to help us identify what microtutorials have more active learning strategies. The interviews and surveys from Study 1 showed that student video choices, strategies identified, and strategies used all matched directly with microtutorial videos that had high and low efficacy status. This shows us that while participants are not math experts, they are also able to identify effective active learning strategies that benefit their own learning. In regards to findings from the interview and survey from Study 1, my colleagues will be going over it in depth tomorrow during the poster presentation. However, I will briefly cover it as well. One of the surveys asked participants to A, identify strategies they think they prefer to use while learning math problems, and B, also identify strategies that they actually apply when solving math problems. As you can see from the graph, the strategies identified and applied matched, indicating that the student's point of view is important and that while they may not know what active learning strategies are in particular, they still rely on them to learn. To reiterate, this finding supports our question regarding whether or not the MFIT survey can differentiate the effectiveness of instruction-based learning strategies that are incorporated in. Overall, the findings from Study 1 indicate that the mathematics fidelity of implementation tool validates new resources with these evidence-based strategies, which assists with calculus learning. In the future, we hope that it will work as a valid tool that all educators, not just in higher education, can use it to gain feedback on their own curriculum, as well as what they select outside of their resources to incorporate. Preparation for MFIT Study 2. Following the completion and success of Study 1, my team has grown, and before I graduate, the following students will be taking over and conducting MFIT Study 2. As previously mentioned, my colleague Holly Kong and Jennifer Ibarra will be presenting the interview and survey portions of MFIT Study 1, and as well as future implications at tomorrow's poster presentations. So if you have a chance, please feel free to check them out. For Study 2, most of the experiment actually remains the same, except that we replace the two high efficacy videos with videos from a new lot of microtutorial instruction created after feedback from MFIT 1 had been incorporated. And of course, we love data. We're always here for the more the better. So we are in the process of recruiting 30 new undergraduate participants, in which case, if you or anyone you know would be interested in participating, please feel free to scan the QR code, let them know, and feel free to email me at stemlearninglab@ucr@gmail.com, and we hope to see you soon. Finally, thank you all so much for listening to my presentation. I would like to recognize everyone at the STEM Teaching and Learning Lab for all of their support and mentoring these past two and a half years. Additionally, thank you to our grant, a new mathematics gateway provided by the California Learning Lab.
Thank you, Prashansa. Great job. Hopefully you can recruit some more participants for the next round. Does anybody have any questions or comments?
Sure, I do. Sorry, I couldn't find my hand in time to raise my hand, but this was great work, Prashansa, and all of your colleagues. I do want to talk with the people at the poster presentations tomorrow.